welcome to another thought provoking episode of my podcast, your go to source for all things neuroscience. I'm your host, Joshi, and joining me today are two brilliant experts from Monash University, Dishita Garg, a leading Alzheimer's researcher, and Liv Dunning, a neurologist specializing in dementia. Thank you for being here, Dishita and Liv. Today, we're taking a deep dive into the enigmatic condition known as Alzheimer's disease. Now, what is Alzheimer's, you ask? It's basically a progressive neurodegenerative disorder that slowly destroys the brain, leading to irreversible loss in memory, thinking skills, and eventually the ability to carry out even the simplest tasks. As the most common cause of dementia among older adults, impacting millions worldwide.
But what would you say goes awry in the brain to trigger this relentless cognitive decline?
Thank you for the question. Stepping into the biology, the key lies in the abnormal buildup of two proteins, amyloid beta and tau. Under a microscope, the brain of Alzheimer's patients reveal telltale signs, clumps of amyloid beta forming plaques between neurons and twisted strands of tau, creating tangles inside the neurons themselves. These plaques and tangles are thought to disrupt communication between brain cells in areas crucial for memory and thinking. As more connections are severed, the brain's integrate network starts to fray, neurons die off, and the cerebral real estate begins to shrink. It's this cumulative brain damage that robs individuals of their cognitive abilities over time.
So Era, what sparks this calamitous chain of events in the first place?
Researchers have several leading theories. One of these amyloid cascade hypothesis, which proposes that the abnormal production or clearance of sticky amyloid beta proteins is the initial trigger that eventually leads to tau tangles, inflammation, and widespread neuronal death. Dishita, can you briefly explain this hypothesis and share your thoughts on its validity?
Absolutely, Era. The amyloid cascade hypothesis suggests that amyloid buildup in the brain is the primary instigating factor that sets up the destructive chain of events we see in Alzheimer's pathology. While this hypothesis has been widely accepted, there is still ongoing debate and research to fully understand the complex interplay between amyloid, tau, and other factors in the disease process.
Thank you for the insight, Dishita. Another school of thought is the tau hypothesis, which flips the script, suggesting that tau tangles inside neurons are actually the driving force behind the disease, with amyloid buildup being a consequence rather than the root cause. Liv, can you weigh in on this theory and share your perspective based on your clinical experience?
You're right, Era. The tau hypothesis proposes that toxic tau tangles may be the major player, potentially even preceding amyloid plaque formation in the disease cascade. In my clinical practice, I've seen patients with significant tau pathology but minimal amyloid burden, lending some support to this hypothesis. However, the relationship between these two proteins is likely more complex, with both playing critical roles at different stages of the disease.
Excellent points from the both of you. While some experts even posit that both proteins may be involved in a vicious cycle, with amyloid and tau pathologies feeding off the accelerating each other in a deadly molecular domino effect. What are your thoughts on this potential interplay between amyloid and tau? Dishita, let's start with you.
That's a great question, Era. The vicious cycle hypothesis is certainly plausible. Given the intricate relationship between amyloid and tau in the brain, it's impossible that initial amyloid accumulation triggers tau pathology, which in turn exacerbates amyloid deposition, creating a self-reinforcing loop of neurodegeneration. However, more research is needed to fully understand the mechanisms underlying this potential interplay.
Thank you, Dishita. Liv, any additional thoughts on this from of your perspective?
I agree with Dishita. The vicious cycle hypothesis is intriguing and it could help explain the progressive nature of Alzheimer's disease. It's likely that both amyloid and tau play critical roles at different stages, and targeting both pathways may be necessary for effective therapeutic interventions.
All right, now that we've discussed Alzheimer's disease and the leading theories on the underlying causes, let's dive straight into the current treatments for devastating condition. Dishita, can you shed some light on the existing treatment approaches for Alzheimer's and where the research efforts are currently focused?
Of course, Ara. So currently, the treatments for AD can be divided into two main categories: pharmacological and non-pharmacological. Pharmacological treatments include your medications, which are included of cholinesterase inhibitors. There is a long list of these inhibitors, but they basically help manage symptoms. But unfortunately, they don't cure the disease.
Well, can you elaborate on how these medications work?
Absolutely. So these inhibitors work by boosting levels of a chemical messenger involved in memory and judgment, which tends to be low in people with Alzheimer's. Memantine, another inhibitor, has a different effect. It regulates brain chemicals called glutamate, which can be produced in excess in people with Alzheimer's and can damage brain cells.
That's helpful to know. A family friend of mine has been described donepezil. Are there any side effects they should be aware of?
Of course, Liv, donepezil and other inhibitors can cause side effects like nausea, vomiting, and diarrhea. Some people might also experience muscle cramps, fatigue, and loss of appetite. It's important to monitor those prescribed with it and report any severe or persistent side effects to their doctor.
So Dishita, besides medication, what are the other treatments available?
So there are your non-pharmacological treatments, and they're equally as important. These include cognitive therapies, physical exercise, and social engagement. We often undermine the significance of improving your lifestyle and being socially and physically active. Cognitive therapies can actually help stimulate the brain and improve your cognitive function. They include a variety of approaches designed to improve memory, attention, and problem-solving skills. I can think of some key therapies right now that have proven to help the lives of many AD patients. Cognitive stimulation therapy, in short CST, is an example of a structured program involving themed activities that actively engage the individual, promoting mental stimulation and social interaction. Memory training, computer-based cognitive training, and reminiscence training are a few more examples of effective cognitive therapies to treat AD.
We've been encouraging my family member with AD to join a local senior centre for activities. Is social interaction really that effective?
Absolutely, there's no doubt. Social interaction can significantly impact a person's mental health and well-being. It helps reduce feelings of isolation and depression, which are really common in AD patients. It also provides mental stimulation, which can help slow cognitive decline.
That's pretty interesting. Well, I've also heard about some new research and potential treatments on the horizon. Could you share some insights on those?
Of course, there is actually a lot of exciting research happening currently, and one promising area is immunotherapy. Now, immunotherapy involves the body's immune system to fight AD. Immunotherapy can be split into two types: active and passive. Active immunotherapy is an approach that stimulates the patient's own immune system to produce antibodies against beta amyloid or tau proteins. Passive involves administering antibodies directly into the patient. Researchers in the field are also exploring drugs that target beta amyloid plaques and tau tangles in the brain, which are hallmarks for Alzheimer's, as discussed earlier.
So, Dishita, you also mentioned about lifestyle practices earlier. How does exercise play a part in improving lives for AD patients?
So, physical exercise is something I've done thorough research on, and it involves a consistent and enjoyable approach. It improves overall brain health and well-being. Regular aerobic activities such as walking, swimming, or cycling improve blood circulation, ensuring that the brain receives a steady supply of oxygen and nutrients. Improved blood flow can help maintain cognitive function and reduce further risk of decline. It also enhances neuroplasticity. This is basically the brain's ability to reorganize itself by forming new neural connections. It helps the brain adapt and compensate for damaged areas, which is particularly beneficial for AD patients.
Well, now that does sound promising. Is there anything we can do now to support ongoing research?
There's always something you can do. Participating in clinical trials is a great way to contribute to research. You can also support Alzheimer's research organizations through donations or just by spreading awareness about their work.
Thank you so much, Dishita, for that. Now, Liv, where is the research on Alzheimer's disease currently focused?
There are many different ways that we're currently researching Alzheimer's disease. Lots of research is looking into the development of the disease, so looking for genetic factors that might increase susceptibility to Alzheimer's, finding early signs of the disease, discovering better ways to diagnose the disease, and looking at how lifestyle factors such as exercise might prevent it. Other fields of research are still looking for a way to cure the disease. Since it's currently known to be a terminal disease, researchers are desperately looking for a way to stop progression of the disease.
So, Liv, in light of the current treatment options for the disease, would you say there's also a particular focus in research on finding better treatments?
Absolutely. I'd say that the majority of the research surrounding Alzheimer's is focused on finding more suitable treatments to reduce the burden of the disease, since current treatments have issues including side effects like nausea, dizziness, and even worsened cognition that make it difficult for patients to take the treatment. In particular, researchers are looking for ways to treat the mental and memory decline seen with the progression of the disease, since this impacts their life very heavily.
So, Liv, has there been any success in the research yet, and what have the studies found?
My most recent study on 500 Alzheimer's disease patients is a great example of where research is heading. It looked into the use of a technique called phase-locked acoustic stimulation on slowing the decline of episodic memory, which is the memory of events and personal experiences.
I've heard of the use of different types of stimulation to improve episodic memory before, but never seen acoustic stimulation used on AD patients. Can you tell us more about phase-locked acoustic stimulation, Liv?
Of course. So how it works is we get patients with Alzheimer's disease to wear a special headband whilst they're sleeping, and this device tracks their sleep stages to play a special sound called pink noise at a particular stage during sleep, called slow wave sleep. This noise then boosts the sleep wave they're currently experiencing to make it bigger, so they spend more time in this stage than normal.
Well, I want to know, and I think our audience will love to know it too. Is there a reason it boosts slow wave sleep in particular and not other stages?
There is. So slow wave sleep is associated with the consolidation of episodic memories. So by boosting the amount of this sleep, we're trying to encourage the brain to consolidate these memories so it's committed to their long-term memory. For Alzheimer's disease patients, we were hoping this would reduce the amount of episodic memories that they lose with progression of the disease. We measured this by having 250 Alzheimer's disease patients use the device every night for 6 months, and 250 of them using a placebo device. We tested their episodic memory using a common memory test at the start and the end of the experiment, and we found that patients using the device had more slow wave sleep and also a slower decline in memory than those who used the placebo version of the device.
That's amazing. So does this mean it could cure the memory issues these patients face?
No, unfortunately, Alzheimer's disease is an irreversible disease. As much as we'd like to find a cure, treatments are more focused on slowing the decline. Like in my study, all the participants' episodic memory got worse, but those who used the device had a slower decline and better outcomes than those who didn't use it.
I can imagine that for those patients, this device gives them a lot of hope and relief for the potential of a better treatment option. Thank you, Liv.
Absolutely. This study has opened up a new field of research into the potential to slow memory declines in Alzheimer's disease, which can significantly increase the quality of life for those suffering with it. Alzheimer's disease is one of the most burdening diseases known, both for those who have it and for their friends and family. By finding these new treatments and continuing our research, we might be able to improve the lives of these people.
That's fantastic. Thank you for sharing about where your research is currently heading, and thank you, Dishita, for earlier too. Also, thank you to all the listeners at home who have tuned in to hear about the disease and its treatment. The first thing to curing anything is awareness. To summarize a bit about what we have learned today, Alzheimer's disease is a neurodegenerative disease characterized by a progressive loss of memory. It results from the buildup of tau proteins and amyloid plaque in the brain, which is why treatments usually involve targeting these buildups. However, these treatments often have side effects, so research research is looking into alternatives such as use of phase lock acoustic stimulation. We hope you enjoyed this episode. I'll see you in the next one. Thank you for tuning in.
Thank you for having us.
Thank you.